World Spaceflight News. Closer look. The Orion Crew Survival System. Casual observers are frequently confused about the difference between true spacesuits for EVA usage, like the Extravehicular Mobility Unit, or EMU, and launch and entry suits such as the Shuttle-era Pumpkin suit known officially as the Advanced Crew Escape Suit, or ACES. For the upcoming Orion missions to the Moon beginning with the Artemis II flight, NASA has modified the Pumpkin suit and named it the Orion Crew Survival System. Extensive video of this suit is not yet available from NASA, but there is some interesting information about its design, and being space geeks, it merits our attention. In 2019, the NASA administrator served as a host of a presentation that focused on the preliminary design of the Exploration EMU, but there was a short segment about the launch and entry suit.
But Dustin, tell us about the spacesuit you're wearing and how it's different than the spacesuit that we're going to wear on the surface of the Moon.
Yes, sir. Good to be here. This suit is the Orion Crew Survival Suit, and so while the mission of that suit is to what we do when we're there, this is the suit that gets us there and gets us home safely. And so this suit is fully integrated with the vehicle from the ground up. So when it's tailored to the human body, it's also tailored to the seat. So we have 100% fit in the vehicle and 100% integration with the Orion ecosystem. So
when you say ECLIS for the audience.
Oh, yes, apologize. We speak in lots of acronyms. So yes, the
environmental control and life support systems.
Yes, sir.
Got it. Okay, so your suit is generally going to be depressurized, which gives you a lot of mobility, flexibility, and of course, when you're flying in deep space, you're going to be just fine without the pressure in the suit. Why would it need to be pressurized when you're in a pressurized capsule?
In a pressurized capsule, we don't necessarily have to be pressurized in this suit. There may be some future cases of decompression sickness mitigation that we might want to use it for, but the primary use is in the case of an accidental depressurization. We can take safe haven in this suit. We'll seek refuge in here. We'll keep the body at 8 psi for a certain period of time, and then we'll drop down to about 4.3 psi, and we can remain there for up to 6 days. And so that's no small feat to be able to live in a volume that's only a couple inches bigger than your body for 6 whole days.
So a lot of people, I think, it gets missed, and it gets missed by a lot of people at NASA, that spacesuits are more than suits. This is, in essence, when necessary, a spacecraft. And same as the space suit that we just saw for the XEMU, which is how we're going to walk on the surface of the Moon, it is a personalized spacecraft for a person walking on the Moon. In other words, so let's pretend you do have an unfortunate depressurization kind of situation. Maybe a meteorite impacted your vehicle, punched a hole in the capsule, you still got to get home. Now you've got a spacesuit that is providing all of your life support. That's the intent, right?
That's correct, sir.
So other than the life support, what parts of the mission will you be having? You'll be able to get out of this suit when you're in deep space.
That's correct. As soon as we get to orbit, the crew will nominally take the suit off. We talked about the word doffing this morning, which is to remove the suit. We'll stow it for the most of the mission, and we won't put it back on until it's time to come home. Once we get home, though, it's not just the suit that provides us safety in deep space. If we had a contingency on landing, the suit is designed for all the aspects of the post-landing safety for the crew as well.
So it has thermal protection?
It does have thermal protection, not the same as what the XEMU has, though, in terms of the radiation environment of space. But internally and under this suit, we'll wear garments to manage our thermal environment with liquid cooling.
Awesome.
The new Artemis suit has been enhanced from head to toe. The helmet is lighter, stronger, comes in more than one size, helps reduce noise, and is easier to connect to the communications system needed to talk to other crew members and mission control. The outer cover layer, which is orange to make crew members easily visible in the ocean should they ever need to exit Orion without the assistance of recovery personnel, includes shoulder enhancements for better reach and is fire resistant. The suit is a pressure garment that includes a restraint layer to control the shape and ease astronauts' movements. A re-engineered zipper also allows astronauts to quickly put the suit on and has increased strength. New adaptable interfaces supply air and remove exhaled carbon dioxide. The suit has improved thermal management that will help keep astronauts cool and dry. A liquid cooling garment worn underneath the suit was revamped to be more breathable and easier to build. While shuttle-era spacesuits came in off-the-shelf sizes like small, medium, and large, the Orion suits will be custom-fit for each crew member and accommodate astronauts of all sizes. The patterns of the suit now minimize the spots of discomfort common during the shuttle era when worn pressurized for long periods of time. The gloves, the part of a spacesuit that receives the most wear and tear, are more durable and touchscreen compatible, and improvements to the boots provide protection in the case of fire, fit better, and help an astronaut move more nimbly. Even though it's primarily designed for launch and re-entry, the Orion suit can keep astronauts alive if Orion were to lose cabin pressure during the journey out to the moon, while adjusting orbits in Gateway, or on the way back home. Astronauts could survive inside the suit for up to 6 days as they make their way back to Earth. The suits are also equipped with a suite of survival gear in the event they need to exit Orion after splashdown before recovery personnel arrive. Each suit will carry its own life preserver that contains a personal locator beacon, a rescue knife, and a signaling kit with a mirror, strobe light, flashlight, whistle, and light sticks. Dustin Gomert is the project manager for Orion Crew Survival Systems, which includes spacesuits, survival kits, life raft, escape ladder, and escape winch. He supported the Columbia team accident investigation and implementation of survival recommendations for the Space Shuttle. Here are excerpts of an interview with him posted by NASA's Academy of Program, Project, and Engineering Leadership Knowledge Services, known by the acronym APPEL.
The ability to survive long-term in this suit is one that we've stretched further than any previous suit that's come before us. This suit has to function unpressurized and perform many functions of mobility, and it also has to function pressurized and perform many functions of comfort, tolerability, and mobility. And it becomes quite a challenge, actually.